So reinforcement is my topic. Okay, so reinforcement in short name we will call as a rebar modeling. Rebar. We will call as a rebar modeling. Okay, some of the people they will call as a steel also. Steel. Because when they are going to start any concrete projects or RCC projects, so steel is the main role is going to play, because they have to purchase all the rod, we can say rod also is steel. Okay, so there will be a huge tonnage of rod is going to be utilized in the reinforcement, because depend upon the requirement of the projects. Okay, some companies they will only design this RCC this reinforcement also. Okay, so you have heard that on AutoCAD also, then there is one separate software is there for making this reinforcement drawing. Some detailing they are going to be provided. Okay, so that also it is going to be worked out here in AutoCAD, but the same thing we can able to do in Revit also, in BIM also we can able to, because why we will do this reinforcement modeling in BIM means we have to take the quantity, because without knowing the quantity, how we will purchase this rebar from the market, because how much tons is required, how many footings we have, for the footing how much the rebar requirement is there, how much the rebar requirement for the column, how much the rebar requirement for the beam, and how much rebar requirement for the floor slab. So every component we should know the requirement of all this rebar quantity, and depend upon the size, because when the rebar came in the site with a huge truck, it will become some number of trucks, some maybe some 10 ton, 20 ton, 30 ton, some 100 of tons will become, because depend upon the project size. So when it will become the rebar, it will become as a lengthy, it will be having a length, and that length is 12 meter is the standard length. 12 meter will be there. So that 12 meter we are going to cut it with the help of cutter, grinding cutter will be there, and we are making some different shapes. Am I right? By using that, making the shapes, we are utilizing that rebar with the help of at site the person who is working this rebar reinforcement, that person's that work we will call as a centering. You know the word centering? So the person who is making this all, bending this rebar, this steel, and making some shapes, so this works we will call as a centering work, centering. So some contractor who will be do only this centering work only, because they will arrange all the rebar for the footing, he will arrange for the rebar for the columns from top to bottom, every floor he will be making. So he is going and making this centering work, and the other contractor is going to fill the concrete on this centering, and it is going to be constructing like that. So one team will be making centering, one team is pouring all the cement, concrete, everything is pouring, and it is filling that. Like that the RCC building is going to be complete. So here RCC reinforcement cement concrete, it's a combination. So the first word is coming reinforcement. So this reinforcement is nothing but steel. So how much the steel is required, what is the size of the steel required, what type of shape we required. So everything we have to make it in a model. Okay, because what will happen at site, the centering people, they may be wastage maybe happen more at site, because what will happen, they will cut the rebar and it is not matching with the site requirement. So what they will throw out. Again they will make some one shape, it is not matching, they will throw out. Like that at site what will happen, they will work, but there is a huge scrap will be downlaid here. There is a many steel is going to be wastage, and when the steel over this if the water will falls, the steel will become rust, and when it is rust, the steel value is going to be waste, because it will be sell with the help of weight, how much kgs will coming. Because when you will purchase from the company, that time they will charge more, depend upon the weight, as per the market rate. But when comes from the company to the site, it is observing all the environment, water, air, everything. The color may be changed and it is become a rusting will be happen. So that time the half of the rate will be not come if you sell that one. Okay, so like that in site you can see many of the steel they are throwing here and there and there, and at last they are collecting all this and they are selling with the help of kg weight, how much weight will be there, and they are getting some money also, because it is not fully wasted. You can use for other purpose also. Recycling work they can do it with the help of this steel. So whatever the wastage is happening at the site, that wastage we have to control by using this BIM model. Okay, each and every component also we can able to give how much the length of the rebar required, what is the shape we required, what is the weight only for one component, that also we can able to calculate. So if you calculate all the rebar, then you will get total calculation, the count, how much tons will be required, and only that much only you have to purchase from the site, from the company. That only your money is going to be wasted, because that much was the only requirement in your project. But if you are purchasing more, if you require 10 ton, but you purchase 20 ton, so what will happen? That 10 ton is going to be wastage at site, and they will sell at with the weight they are going to sell. Many of the sites you can see, many of the site engineer people, they are selling this one. Some truck will become and they will fill this all rebar and they will go to the garbage shop where they are taking this all things. So they are waiting, and whatever the amount, some 10, 20 rupees, 30 rupees kgs they are going to give it, and that money they are taking. Because the client is not looking after it. He wants the building completion, that's all. What is happening internally, he doesn't bother about all this. But that is the thing here BIM is telling, you have to save that money, because what you are wasting that in the purchasing the steel more, which is not required at site also, so that you have to make it control here. So how it will be going to make it control? If you are going to make it model, and that model you have to give the each and every component the quantity, the weight, the shape, the size, everything if you give it, and any detailed drawing, so then the contractor only that much quantity he will be purchased. Because as per your model preparation you got some 15 ton. The weight you required, this rebar, this is the size, this is the shape you required. So only that much 15 ton only he will purchase. Why he will purchase more? It's a waste of money. So for that saving that money, the contractor and the consultant or the client has to be prepared this model in BIM. Then only we can able to give the quantity as per the requirement, accurate it will become. So how we will make this model in a rebar in BIM? Okay, so whatever the component will become, the footing, the foundation we will prepare the reinforcement. For the structural column also we will prepare the reinforcement. Beam also we will prepare the reinforcement. Floor or slab, that also we will prepare the reinforcement. Staircase, in a monolithic staircase also we are going to provide the reinforcement, even the ramp also. And some of the RCC wall, concrete wall, the retaining wall, the block wall, it's also going to become this reinforcement. So these are the components where we will use this reinforcement. Okay, apart from this, the other component we are not going to utilize this reinforcement. Rebar is not going to be utilized. Okay, so these components only we are going to be make the model of reinforcement. So that is the reason in a structure, the Autodesk people, they have given this reinforcement separately. Okay, so how it is going to be worked out, and what is the utilization of this reinforcement. So everything we have to know. So here in the reinforcement also we will have different shapes. That shape we will call as the rebar shapes. Rebar shapes, and that rebar shape is going to be, get the symbol here M, and it is going to start from M00, M01, M02, like that. They have given some numbering with alphabetical M. So here one number, one shape will be there, because the bending shape, because with the help of machineries they are making the bends, because in site way required. Some of the slab we are going to put lapping. So the lapping we have to put some bend, 45 bend or 90 bend, whatever the shapes we require, that we have to do it here. So that all shapes we will call as a rebar shapes. So here in BIM also will be have this all shapes families will be there. So each and every shapes will be have one family. So there is a multiple families will be there. You just go and choose the shape, it will become. So here some of the reinforcement we can do automatically. Automation is also there. Some of the reinforcement we can do manually also. So just you place one, remaining it will become continuously. So that process will be there here. We can able to take it. So rebar shapes also we have to select here, and then the rebar sizes also will be there. So here different sizes. So minimum diameter of the rebar is 8 mm. 8 mm is the minimum diameter. 8 mm, 10 mm, okay, then 13 mm. These are the sizes which we are going to take. That is outer dia, not inner dia. Because the circular objects, when we are going to take some OD and ID will be there. Inner dia, outer dia. But here the rebar we are calculating the sizes with outer dia only, not inner dia. Okay, 13 diameter, 15. Okay, so 15, next 17, like that. There are multiple dias mm will be there. 19 up to 50 mm also we will get the diameter. So there are multiple sizes. So depend upon the size of your component, this diameter is going to be increased, and depend upon the load, how much the load is going to be applying for the component. Because your building is having some high rise, some 50, 60, 70 floors. So that time your reinforcement size is also going to be increased, because load bearing capacity is more. So your reinforcement also it's going to be get more capacity, more sizes. So diameter is going to be increased. So like that, there are multiple rebar sizes will be there. You have to choose the size, then rebar shapes, and based on the shape you have to go and provide the rebar for each and every component. And here also the component of making the rebar, it's also going to be show you the model with solid objects. It will become, and you can able to check the length, the bending hooks, so everything it will become. What is the radius of the hook, what is the bending moment, the radius it will be coming. So everything, the properties is going to be comes here automatically after making the model of rebar. Okay, so here different shapes will be there. So here if you go M00, there will be a straight shape. If you go M01, then it will become some shapes like that. It will become some different shape. Like that it will become. If you go M02, maybe it will become like that. So these are the shapes will become. So like that there are multiple shapes will be there here. You can utilize which shape you require, you can work out for that shapes. So here how we will place the reinforcement here, because for the footing I just explain you, because if you have the footing like that, this is a front view. Okay, so here the reinforcement will become like that. So by applying, because this is the RCC, this outer part is the RCC. So inner we are going to put some dotted line, this dotted line is going to be visible. This will be called as a clear cover area. Clear cover area means exactly the reinforcement we are not going to place exactly the outer of that component. If the footing is there, the outer shape of the component, we are placing this rebar inside that concrete. So that part we will call as a clear cover. From outer face of the RCC to inner, some space we are going to give. That space is minimum 25 mm, maximum 32 mm we can able to give. So 20, 25 and 32. These are the space, and that space we will call as a clear cover area. Clear cover. Clear cover. Cover area. So that is covering the component. So we have to place here that clear cover. We are going to place here bar, rebar, that we will call. So here one rebar, here one rebar, here one rebar, because it should be inside the clear cover only. And bottom also we are going to put the reinforcement like that. Okay, so the reinforcement which you are placing, the top, that we will call as a top major bar. Top major bar. Rebar means bar. And the reinforcement which you are going to place bottom, that we will call bottom major bar. Top and bottom. And that we will call as a major bar. And exactly below that, if you are going to place one more rebar like that, and it will become the shape this way. So that we will call as a bottom minor bar. So major bar, minor bar, like that. They are going to indicate the name in this way. Because the top of the bar we will call as a major bar, the bottom bar we will call as a minor bar. So top, bottom, like that it will be there. And whatever the shapes is going to become, that shape is rebar shape. Okay, so here we will indicate in such a way. So, and here the top is also going to be covered with this. So when you are going to place the rebar, it is going to be touched with the clear cover line. So there will be one green color line will become, and that line is going to be called as a clear cover area, and the space is going to be provide minimum 20 mm, 25 mm and maximum 32 mm is the space we are going to provide the clear cover area. And within that clear cover area we have to place the rebar. So after placing this rebar, if you see in top view, it is going to be look like that. The foundation is going to be look like that, because all these rebars is going to be placed. So from one rebar to the another rebar we are going to put some distance, and that distance we will call as a spacing from one bar to the another bar. And that spacing we are going to provide from one bar to another bar. The minimum spacing is 100 mm. Minimum is 100 mm, maximum you can provide up to 350 mm. Depend upon the component size and depend upon the rebar size we can able to provide. So from rebar to rebar, the minimum distance that we will call as a spacing between the bar. From one bar to the another bar we are going to provide some spacing, and that spacing we will call as a rebar spacing between the bars, and that we will also consider here. So here for the footing, this is the shapes is going to be provided. But come to the columns. If you are going to provide the reinforcement for the, here the footing, concrete footing will be there, above there will be a columns. Okay, so in the columns we are going to put the rebar from top, and it is going to become straight, and after coming here it is going to be put some bends, and that bend is going to be comes with the 90-degree bend that we will call as a hook. So here 90-degree hook will be there, and it is directly bending through the footing directly. It is touching below, or it is going to be get half of that footing inside, because it will become like that. It will become like that. So here we are going to provide this kind of bar here, and in column also will be have a clear cover, again the clear cover. So in the column we are going to put the clear cover is 25 mm. For the footing we can also put 20 mm the clear cover, but the column we have to put 25 mm the clear cover space. And in columns we are going to put here shapes of the rebar will become like as a ring, and this ring we will call as stirrups. You know stirrups? It will become like that, stirrups. Okay, stirrups. So this is bar, but they are going to making a round shape, and that stirrups will be having two hooks, single hook. There will be hook will be there. If you see these stirrups, it will be look like that. It will become like that, and there will be a two hooks will be there. This we will call as a hook, two hook. So like that stirrups also going to be. So from one stirrups to another stirrups there will be a spacing we are going to keep as 150 mm. We have to keep 150 mm spacing from stirrups to stirrups. This is the standard for the beam. We are going to take the design basic or based on the design. We have to put the stirrups distance from one stirrups to another stirrups. We have to put 150 mm is the gap, and the bar which is coming from the top, it is going to be come from top and it is going to be inserted into the footings. If the column is continue up the top floor, so each and every bar they are going to make the joint, and the joint is with the help of couplers. They are going to put some couplers, and the coupler is going to be have two types. There is one welded couplers and another is threaded. So some of the internal and external thread they are putting in the couplers and they are jointing, because the couplers is going to give the stiffness of the rebar, because the rebar length is more. If it is continue without support, maybe it will become bends. So that's the reason in between bar to bar we are going to put some couplers. So that couplers is also going to be utilized here. We can able to put many couplers here, because if your bar is coming like that, so in the bar we are going to put some coupler like that. Again one more bar will be there like that. Continuity will be go past. So this we will call as a rebar coupler. Rebar coupler. So here for continuation of rebar from one length to the next length, in between we are going to put some coupler. So coupler also we have to get the count, and we can able to place all the couplers here. For jointing purpose we are utilizing this coupler. And for the columns, again for the beams also we are going to use the stirrups. And in beam also we are going to put the stirrups distance is 100 mm. You remember, for the column we have to place the reinforced stirrups distance is 150 mm, but for the beam we have to put 100 mm standard. We have to maintain 100 mm only stirrups distance from one stirrups to next stirrups. The bar will become straight only. There will be no bends, nothing. But the column will be have the bends like that. It will be come from the top and it is going to be bent throughout the footing. And there is a number of stirrups will become as a column continuation 150 mm. In beam also the stirrups will become. So like that we have to put the distance here also for that beam also. So the from column, if it is coming any beam here, then for the beam also the straight rebar will become, and it is going to insert it inside the column, and there will be a number of stirrups will become. So here if you place one stirrups, then continuation we can provide the spacing, and it will become multiple stirrups once. So you have to provide one stirrups, and the continuation if you require the spacing, if you give, it will become multiple stirrups with the same spacing which you have going to provide the values. So here the stirrups also we are going to be placed here. So rebar stirrups like that, all the beams is we going to place manually. We have to place it because the beam length is long, so then we have to joint the rebar from one rebar to another rebar with the help of couplers. If the beam length is small, so we have to cut the rebar. By making the shape, we are making the stirrups jointing, and it is going to be fixed with that. So when these stirrups, when they are going to make it joint, so with the help of winding wire, it is going to be tie. The tie is with the help of winding wire. With the help of winding wire, it is going to be tie the stirrups. So this all winding wire is also made of MS only. This stirrups is also made of MS. So this all rebar is consist with MS only, mild steel. So the person who is working for this centering, one of the or two of the guys will be from the mechanical, because it's MS, this all steel welding, this comes under mechanical technical side. So that's the reason some people will be have the mechanical people who is working in this rebar placement, rebar designing, everything will be there here. They are going to be work out for the. So after making the model, have you heard the word BBS, bar bending schedule? We have to prepare the schedule, bar bending schedule we will call. Some people they will do manually. There is an Excel sheet will be there. In the Excel sheet nothing but they are going to take the quantity. That we will call as a BBS. BBS is the full name is bar bending schedule. Bar bending schedule means nothing but the rebar, the shape, the size, how much it is going to become, that everything is going to be give the schedule. So that we will call as BBS. So here in BIM also we will take this BBS report. BBS report also we can take, and it is possible here because after completing the model we have to go for the BBS. That we can do it. Okay, so here the beam also we will put this reinforcement like that. Floor also will be the same as footing, how you place for the floor. But in floor sometimes what will happen, the floor size may be changed. So that time the floor may become like that. So that time we are going to put the reinforcement like that from floor to floor. So that part we will call as a lapping rebar, we will call that name. Lapping is nothing but it's coming slopes, it's coming some bends, that way. So the floor also it will become and bend it will be go. So the bending part we will call as lapping. So here in floor also we will able to make the reinforcement lapping here. Okay, so here this all things we can able to do. So practically I will show you each and every, and then you can able to proceed for the same. Okay, so here one more reinforcement also we are going to work, that is fabric reinforcement. Fabric, you know fabric is nothing but it's a mesh, because the thin wire it will become with circular will be there. Some of the people they will use this mesh for the windows also. Some people they will use this mesh for some other purpose also, for closing the area, something they are going to utilize for this mesh. Okay, so that mesh we will call as a fabric reinforcement. So when we are going to use this fabric reinforcement, wherever the slab thickness is less than 100 mm, wherever the slab thickness, wherever the RCC thickness is coming less than 100 mm, those places we are going to use this fabric reinforcement. So here the fabric reinforcement is also there. We can use this fabric reinforcement wherever, because some peoples in the houses they are going to put some shelf. So in the shelf how the thickness will become maximum maybe 75 mm, maybe 60 mm, maybe 50 mm. So in that places rebar placement is not possible. So that time they are going to use this mesh. So by making this mesh, and they are placing all the cement on that, and they are making the plastering. So it is observing that one. So like that it will be happening the reinforcement in the. So that type of reinforcement we will call as a fabric reinforcement. Fabric. We are not utilizing the solid bar. We are utilizing the mesh. MS mesh will be there. Wire mesh we will call it. So that mesh we are going to utilize here for making the fabric reinforcement. So some cases we are going to utilize this one. And here come to the Staircase also we are going to utilize this reinforcement, because the staircase will become like that. Okay, so in the every staircase we are going to utilize this rebar like that, and in top or bottom it's going to become like that. So every area we are going to utilize this rebar, this will. So shape and size it will become continuously. Okay, so one rebar will be go straight, then the rebar will become on. So here also it will be look as a floor, because the thread and riser, it is going to become with bends like that. And one above the other, they are going to keep the rebar shapes. So in reinforcement, we can, in the staircase, we can also going to use this reinforcement staircase. A ramp also we will utilize this one. Even for the wall also, RCC wall. In RCC wall, some of the wall you can see the retaining wall. The retaining wall will become outer boundary of your building. Maybe some compound wall, we are going to utilize this rebar there also. So in a retaining wall also, how we are going to place this rebar in columns. In retaining walls also, we are going to place these rebars in between the wall to wall, we are going to making the joints. So that also possible, we can able to do it here, wherever the retaining wall is going to become, or this block wall. So that area, the shear wall, that area we are going to utilize this RCC wall for the reinforcement. So this all reinforcement, wherever the concrete and cement is going to be utilized, that area we are utilizing this rebar modeling, and we are utilizing this rebar shapes, stirrups, that everything is going to become in that place. Okay,